In a fluid system, it's often necessary to determine how much fluid is used, moved, or produced. To provide this information, different types of flow measurement devices are used. Not all flow measurement devices work the same way. Some measure the actual amount of fluid that passes through them. We'll call them direct flow measurement devices. Others measure process conditions that are related to flow, such as pressure. Then they convert those measurements to flow indications. We'll call them indirect flow measurement devices. This nutating disc meter is one device that measures flow directly. It gets its name from the action of a disc located inside the meter. The word nutate means to wobble or roll about an axis of rotation. During operation, fluid enters the meter through the inlet. The fluid flow causes the disc to rotate much like a slowly spinning top. As the disc rotates, specific amounts of fluid are trapped above and below the disc. If a change in the process causes the flow rate to increase, the disc rotates faster, but the same amount of fluid is passed along with each rotation. A counter mechanism counts each rotation of the disc to keep track of how much fluid is passed through the meter. While direct flow measurement devices measure the actual amount of fluid that flows through them, some indirect flow measurement devices rely on some type of energy conversion to indicate flow. One of the most common devices used for indirect flow measurement is an orifice plate. An orifice plate is basically a plate with a hole or orifice in it that's used to restrict the flow of fluid through a pipe. More specifically, the orifice plate causes an energy conversion to take place. As fluid flows through the opening in the orifice plate, its pressure decreases and its velocity increases. The conversion of pressure to velocity causes the pressure on the downstream side of the plate to fall below the pressure on the upstream side. A device such as a differential pressure, or DP cell, measures the difference between the two pressures and provides a corresponding flow rate signal. If the flow rate through the opening in the orifice plate increases, the difference between the two pressures increases as well, and the DP cell provides a signal representing a higher flow rate. By converting energy from one form to another, an orifice plate creates a differential pressure and enables the flow rate of a fluid to be determined indirectly. Accurate level measurement helps ensure that proper amounts of materials are maintained in plant systems. One device that's sometimes used to measure level in fluid systems is a displacer. A displacer operates on the principle of buoyancy. This principle states that when a body is immersed in a fluid, it's lifted or buoyed up by a force that's equal to the weight of the displaced fluid. To see how the principle of buoyancy applies to a displacer, we'll use this illustration of a displacer attached to a container of liquid. Liquid levels equalize in containers that are connected together, so the level inside the displacer's chamber stays the same as the level in the container. A weight hangs in the chamber and is connected through a linkage to a transmitter. The higher the level of the liquid in the tank and the chamber, the more liquid is displaced by the weight, and the greater the buoyant force. The increase in buoyant force causes the weight to rise slightly in the chamber. The linkage transfers the movement of the weight to the transmitter, which in turn transmits a signal representing the level to an indicator or a controller. Another way to measure level is to use a device that measures head. Head can be thought of as the pressure exerted by a liquid as a result of its height or depth. For example, the pressure exerted on the gauge mounted near the bottom of this container depends on the depth of the liquid. Now, the density of a static liquid will also affect pressure, but in this case, the density doesn't change. If the level of the liquid increases, the pressure exerted on the gauge increases as well, and the gauge converts that pressure to an indication of level. Temperature is a key process variable that's commonly monitored in plants. Temperature can be measured using different types of temperature measuring devices. One of the most common temperature measuring devices is a thermometer, such as this liquid in glass or liquid-filled thermometer. It consists of a glass tube which contains a liquid and a calibrated scale. This particular scale is in units of degrees Fahrenheit, but other scales, such as degrees Celsius, are commonly used. A liquid-filled thermometer operates on the basis that most liquids expand when they're heated and contract when they're cooled. Increases in temperature cause the liquid to expand and move up the tube. Decreases in temperature cause the liquid to contract and move down the tube. The level of the liquid in the tube indicates the temperature of the substance being measured. Another device that's often used to measure temperature in industrial applications is a thermocouple. A thermocouple consists of two wires made of dissimilar metals, which are joined at one end so that they produce an electrical voltage. The other ends of the wires complete a circuit to a measuring device with an indicator. When the temperature sensed by the joined ends changes, the voltage generated by the wires changes as well. That voltage is detected by the measuring device and displayed as a temperature indication. In this topic, we focused on the measurement of four common process variables: pressure, flow, level, and temperature. We looked at several devices commonly used to measure these variables. Now let's try some practice questions that relate to this material. Another pressure element that's used in industry is a bellows. A bellows is basically a movable accordion-shaped tube. In this arrangement, one end of the bellows is connected to a pressure source, while the other end is connected to a mechanical linkage that's used to move a pointer up and down a scale. When pressure is applied, the bellows expands. As the bellows moves, the mechanical linkage moves the pointer as well. An orifice plate is a plate with a hole in it that's used to restrict fluid flow through a pipe so that flow can be measured indirectly. In this arrangement, a gauge that's mounted near the bottom of a container provides a level indication based on the liquid's head, that is, the pressure exerted by the liquid as a result of its height or depth. A thermocouple consists of two wires made of dissimilar metals, which are joined at one end so that they produce an electrical voltage. The other ends of the wires complete a circuit to a measuring device with an indicator. When the temperature sensed by the joined ends changes, the voltage generated by the wires changes as well. That voltage is detected by the measuring device and displayed as a temperature indication. In this heat exchanger, steam is used to heat water for a process. If the temperature of the steam entering the heat exchanger suddenly increases, what will happen to the temperature of the water leaving the heat exchanger? In this arrangement, a single valve is used to control the flow of liquid from a container. Suppose the valve is moved from the fully closed position to the fully open position.